All right, welcome back, scholars, to our second to last lesson in this voluminous unit. So, in our previous lesson, we spent a significant amount of time discussing the scale factor needed to modify the output of the function, right, which stretches or compresses. Bless you. Thank you. The vertical orientation of a function. So obviously we need to spend a little bit of time talking about the inputs. All right. So things will definitely feel uncomfortable, and it's a lot of intuitive thinking at this point. But every weekend, Elena takes a walk along a straight road in front of her house for 2 miles, then turns around and comes back home. So as we can see, and we're going to assume Elena walks at a constant speed. So she's able to get the 2 miles done in, let's say, 1 hour, and then return home. Right? These miles represent her distance from her home. I would like for you to sketch a graph of the function g that gives her distance g of t in miles from home as a function of time t if she walks 4 miles per hour. Write an equation for g in terms of f. Be prepared to explain why your equation makes sense. Now, once again, I am going to overemphasize. She is merely walking 2 miles from her house before returning, but at a constant rate of 4 miles per hour. Take that into consideration when sketching your graph. What would the graph look like if Elena walks 1 mile an hour for the 4 miles, right? 4 miles in total because 2 miles out, 2 miles back in. But we're changing up the rate at which Elena is walking. Sketch it and write yet another expression for g in terms of f. Now, with a Ferris wheel, it has a circular behavior, right? So assuming that our person is at the tip top of the Ferris wheel, this is their descent from the maximum value of the Ferris wheel. After 80 seconds, they are at ground level and can exit the ride. So Claire decided after her first go around on a Ferris wheel to try 2 other Ferris wheels. The first one, the wheel is twice the height of f and rotates at the same speed. So this should be very straightforward, and that is function g, right? The first wheel is twice the height. So a very important component right now is determining, well, what input and what output, or whether the input or output represents the height, and what does the input represent if it's not the height, and vice versa. The second wheel is the same height as f, but rotates at half the speed. The function h gives Claire's height, h of t in feet, t seconds after starting her descent from the top. You should notice that you will not have an output values for every input of the h of t function. I would probably pause the video here because if you move on to the next slide, you're asked to determine if there's enough information to find exact values for h of 20 and h of 60, why or why not, and then expressing both of those functions from the previous screen in terms of f. Finally, we arrive here. Function k is a transformation of function p due to a scale factor. Write equation for k in terms of p. Right, so we have function k is our dashed line. Function p is our solid line. Right, so what can we possibly do to p in order to create k? Take a look at the inputs, take a look at the outputs, and consider what is changing here. At this point, we've been working with transformations for quite some time, so you should have at least some idea. But if you don't, make sure you ask questions. And then make sure you sketch a function, a graph of the function m for this particular graph. The highest point on a graph of P is 1, 2. What is the highest point on the graph of a function n, where n of x is equal to P of 5x? Explain and show your reasoning. So if we're taking an in-depth look at this particular, can I not copy and paste? Oh, there we go. Oh, change. All right, n of x equals P of 5x. What you should do is select specific points, right? N of what value would be the equivalent of P of 5x. In this case, right, we have x being 1. So that's something to take into consideration when you're going to algebraically manipulate this data to determine what the corresponding input and output on the function n of x would be. The point furthest to the right on the graph of P is 4, 0. The point furthest to the right on the graph of function Q is 18, 0. Write a possible equation for Q in terms of P. Once again, I'm going to overemphasize what is changing, the input or the output. That should be first and foremost what determines where your scale factor is going to be located. Will it be attached to the input, or will it be multiplied to the entire output? Things to consider. And then in our final slide, you'll check yourself. Here we have a bunch of different algebraic equations provided to us, and we need to identify what transformations would take the graph of f to h, j, and k respectively before pausing at the enhancement opportunities. I know I didn't really explicitly demonstrate anything, but once again, we have been working with transformations for quite some time, so I am interested to see how you're able to process all of this interpretation of notation in English, especially distinguishing between an input and an output. If that is something that you still are struggling with, please, please, please make sure you bring it up during our class time together.